spring. Anyway, so let's just get right to it. I tend to run through these really fast, so if anyone thinks I'm going too fast or being unintelligible, just scream at me to calm down and, you know, take a Xanax or, is this vodka? I could use that instead. Anyway, so this is a talk, oh, it's loud. Okay, this is the talk on .NET reversing. I'll just get right into it. First I'll start off with who the hell am I? Basically I do application security for financial companies. I'm not a consultant. I just been working in finance for I guess about 5 or 6 years. And before that I worked briefly for the man. In a different sense, I worked for the military for 2 years, and then before that I was kind of more into the startup, .com scene before the bubble burst, and we were really all upset at the death of pets.com and company. Anyway, so I've been kind of obsessed with Microsoft and Microsoft produced products. I do own the Browns even, and I tie that all back to a traumatic incident I had when I was 8 years old when I wrote my first ever computer application in QBasic. It's fathers don't let their daughters grow up to write QBasic. No. Also, a bunch of you are probably familiar with me more about because I just run the security reactions blog. We have over 500 submissions in the queue, so thank you all, anyone who has submitted and who enjoys it. And I'm also out of my mind. So why am I doing a talk on .NET? It's been around forever. It's been around for what, 10, 11, 12, 13 years? I don't even remember anymore. It's been around so long. And it kind of occurred to me to start talking about it because nobody else is. There's all these tutorials on how to break Java, on how to do Java reverse engineering, decompiling Java, breaking Java, the obfuscation, objects deserialization bugs in Java, this, that, and everything. Everyone's freaking out. Java has to get patched every other week, and people are ripping their heads out. Why isn't this level of destruction being reaped on .NET? Is it just not, is it more secure? Did Microsoft actually get something right? Is it just not widely used? No one cares about it? That never really seemed to be a, deal breaker for the hacker community. So, there's nothing I can say about Java that hasn't been said by people way more experienced, way smarter, and maybe way more erudite than I am. It's the horse isn't even a horse anymore. It's like prepackaged and being shipped out to, be put in hamburgers that were not supposed to be there. It's just, let's talk about something else. Let's talk about Microsoft's sort of runoff. It's like the new Coke of languages. So Java came out and Microsoft was like, nope, we gotta make a copy of that. So. And you can see here from this infographic that isn't showing up very well, but that I stole from BruCON, so I'm sure you can find it on their blog, that .NET and Java are, there's a little bit of swapping here, but you see that code quality is both a top issue for .NET and Java, and they're similar in a lot of different ways, which I'll get into. But there's bugs in .NET. The distribution of bugs might be different, but and there are applications, important ones that are written in .NET, I won't name names. They've got bugs in them. Let's go find them. Why aren't we seeing more of this? Are people doing more talks on it? Is it not cool? Then I'm lame. Alright. So let's just get right into it. This is not going to be anything new and groundbreaking. This is a talk on just a subject that nobody is, basically I had to spend just a month putting together basic information about this. This is how disparate and kind of scattered over the place information about .NET reversing is. So let's just start with the basics. What is .NET? What makes it special? Whatever definition of special you want to use. So the thing about .NET, and the reason I don't remember the design decision behind this, maybe someone at Microsoft who still works there when this happened, can explain better, but the idea was that you could write anything that, as long as it was a .NET supported language, C#, VB.NET being the two most popular. I've heard rumors that there are F# developers somewhere in the world. I've never actually met or seen one, so I don't know if they are actually sort of folklorish, or if anyone, has anyone here written an F# application? Okay, I don't have to buy anybody here. Like, make them a new god, because I don't believe them. The purpose is, all these languages which is whatever .NET support language you get, you choose, you write it, gets converted into CIL, Common Intermediary Language Code, and then the Common Language Runtime implements the intermediary language code, not your code. So what does Common Intermediary Language look like? Sort of looks like assembly. I don't like to say that because that's mean to assembly. I like assembly. But it is stack-based. It does have, basically I just wrote a little .NET. This is a C# application that pops up a little message box. It has a little message to say how I feel about, C# in general when I write it, my general mood. And this little box, you click the little OK button, it goes away. That's what the code looks like on the top in C#, and that's what the code on the bottom looks like in Common Intermediary Language. You can see that it loads the string onto the stack or whatever. It's using some system internals this is basically libraries inside the .NET runtime that it's calling to instantiate a message box. It's loading the string that here's the string that the message box is going to inherit, and then pops it. The pop is before, and then it returns. And another similarity between Java and .NET, I'm getting a little mixed up now because I am getting the shakes. So, is that they're both easily reversible. If nobody's been doing anything to your .NET assembly, it's very easy to get the code back. And that is because of the inherent what's the word I'm looking for? Just the inherent consistency of the .PE file format. There's an entire, I think it's 600-page ECMA 336 through 35 that defines the Common Intermediary Language, and another one that defines and it's all documented on Microsoft's website, this file format. It's a specific format. It's the same for every assembly, the information that's going to be in there. And you get everything you need pretty easily. As long as you know what this format is, you can get all the information you want, assuming that no obfuscation has been done. And we'll get into how you can overcome that later. But all the information about the binary, everything you'd expect to want to know about a program is easily retrieved from this format. And it's not encoded in any way, it's not encrypted, or, they don't even base 64 a lot of it. It's just all, and I'll show you in a later slide, it's all mostly plain text. And so you have the things like your user strings, your namespace strings, your methods, unique identifiers for your assembly, so the runtime can tell what is what, any sort of binary data, pretty much everything. Like I said, types, methods, fields, properties, events, all your little programming language essentials, just all in there for you to find. I'll go into the metadata stream one a little bit deeper. I could probably do an entire presentation about this format in and of itself. There's a lot of these things that I could do an entire presentation on, but that would be really boring. And I don't want to, I wouldn't want to do it, and I don't want to put any of you through it. So if you're more interested, just go to the Microsoft blog, look it up. I'll try to post a link to it. I have, that's the one link I don't have reference in here. Sorry, I screwed you once again. So here's the things that are in the metadata table. Again, just more stuff, properties, methods, fields, types. And it's all in a very nice, easy to read table format. You can parse these tables once you know how the tables are formatted, how they're labeled, what are the little items in each table row, columns. Once you know the format, you can pull the stuff out really easily. Somebody already wrote a program to do that. It's called CFF Explorer. I love it because it has a complementary, its icons of chili pepper, and its sister application is taco, and everyone loves tacos. If you don't like tacos, you should leave. I'm serious. But you can just browse this just in a nice little tree, hierarchical fashion. Just go into your method table, your field table. It's all there. Somebody already wrote this for you. You can want to write it. I tried to write it myself in Python just to say that I did it. I don't recommend that. That's probably why I keep getting alcohol. And so you can see how it's all just, look, classes, modules, all in ASCII. Oh, there, not hard. I'll stop for a moment. I really do. I love waffles, they're the best thing ever. So because of this, because this is so easy to to parse to get the code that you put in back, obviously they wrote a bunch of obfuscators. They don't like that. They want their intellectual property to be safe. It's a great thing to sell to people who don't understand anything about reverse engineering because you think that it solves all your problems. The pirates and the hackers can't get your code anymore. And there's there's a handful of ways to do this. So I took the ones, I kept saying the most widely used. I don't know that. I can't claim that. I haven't done any sort of statistical analysis. I used the ones that showed up most often when I searched for obfuscation in Google. Just gonna be honest. And these are the things that they do. Smart Assembly is Redgate's product. So they invented the disease, the Redgate reflector, which decompiles your code, and then they gave us the cure. Their own obfuscation product. Awesome. Great. This is a great business model. I love it. I wish I had that sort of business acumen. I would be making more money than I do now. So they have things, and these all are exactly what they say like. As string encryption, it's sometimes encryption, it's sometimes encoding. Only your CTO can tell you. Dependency merging takes all those little DLLs and references and bundles them up into one big exe. So it's for portability, but it also makes things a little bit harder because it's not as, we'll go into what it looks like to actually reverse one of these things out. It's not as good and nicely compartmentalized when you put them all in there. That also allows you to do these other things, the method parent and control flow obfuscation. When they put new methods, they'll move classes around, play around with the public-private class method permissions. It used to be in class A, now it's in class B. They'll put in a bunch of code, nice modular code. They'll turn to spaghetti. They'll insert garbage code that does nothing, just to kind of throw you off. They'll take the symbols, they'll rename them to unprintable characters, so if you try to convert it back into C#, you get something that doesn't even look like something anybody wrote. All your variable names, your method names are all gone. You can't get those back, by the way, unfortunately, because they don't save them anywhere, because they're smart. And the other things, tamper detection, to avoid what I'm going to show you later in this presentation. And our resource and assembly encryption, exactly what they sound like. Sometimes it's encryption for reals, and sometimes it's K64 for play. So I just wanted to go on a little tangent. I kind of already did about Redgate Reflector, and the kind of sort of not really irony. I know everyone's like, that's not irony. They knew we were going to do this. They knew that we were going to put Reflector inside Reflector to see what happened. And I've never been rickrolled doing reverse engineering before. So well played, Redgate. Well played. But this is what the symbol deobfuscation looks like. They basically just converted it all to garbage. But they left some modified, just to mess with my mind and let me know that they know I'm watching them. So how do we get over this? Like I said, we can't get the symbols back. They didn't save the names, so they're not in there anymore. We can convert them back to something printable, something that looks like English. Usually it's just incremental class A or NS 130, 134, 135, 136. We can try to get out the proxy code, the jump classes. Sometimes it forms a little pattern. You can kind of say, oh, I've seen this. I've obfuscated these 5 things, and I always see this really mucky-looking code in the middle of it. That's probably garbage code. It never gets called anywhere. It's a little bit hard to get rid of that or to determine if it's ever getting hit on. We all know this is a common problem in computer science, a halting problem, we've all heard of it. Sometimes it's just better to leave that stuff in there. It's also sometimes hard to tell whether it's obfuscated code or just really poorly written code. I've gone back and forth on this on a few pieces I've seen. You can move your methods back to their original classes. That's usually a little easier to figure out. You can remove the tamper detection pretty easily. Most applications really are just relying on the strong name signing, which I'll show you is pretty easy to get around. And like I said, sometimes you can just leave it alone. Sometimes, if it's in a state where you can just read through it, you're just going to have to treat it like really, really badly written code. I don't know if it's garbage, if it's obfuscated, or if this person was on meth. So we're going to go into proof of concept. Like this before, I heard you like reversing, so I put a reverser in a reverser, so you do a reverse or your reverser or DP or whatever. I'm really proud of this image. I made it myself. Exhibit posted and everything. So it's good to have a goal when you go in this. I have attention deficit disorder, like I'm sure that 50% or more in this room either have or claim to have. And it's good to figure out what you want to do before you start doing things, because you will just end up on this kind of path of not goodness. So we got to do a couple of things. This is what we have to do if I want to modify this just to show that I can. Just to ensure I can get around the tamper detection. It doesn't matter that it's obfuscated. I can still figure out what the code does, and I can put my own code in there. That's great. You want to write some malware, you want to crack some softwares, or do other bad things that you should never ever do. And I'm not condoning that you do them. Please. We're going to add new functionality. I think Reflector was missing a certain something. A little je ne sais quoi. It's not there. Sorry, I have terrible French issues with French. Like Belgium. Like I should. Whatever. We got to get rid of the strong name side, because that's what's preventing the modification of Reflector. We got to identify, in Reflector you'll see there's a toolbar, like every app. There's a toolbar that launches certain pieces of functionality. I want to have a little icon of my own that launches my new functionality, the functionality the Reflector really needs. So I need to put a new icon in there. How do they make icons? I don't know. Do they have a bunch of files on the file system? Is it bundled in there somehow? I don't know. I gotta locate the event handler for the icon clip. Not as easy as it'll be seen when you go through this obfuscated code. It's really messy. Then I decided to do this. People always ask me, why didn't you just decompile this into C#, write your new C# code, and recompile it? You get into a lot of obfuscation where it is just easier to put the IL in there than try to recompile code. If you've ever gotten code from a developer, even when it's not decompiled code, getting it to build is basically like doing some sort of weird voodoo magic, like a headless chicken, and it's like, oh, it's all there, it's all in the zip, just run it, just put it in Eclipse, or put it in Visual Studio, or run GCC on it, and it'll run, it's fine, it runs on my machine, and you must be doing something wrong every single time. So it's just easier putting the IL in there. I know people don't like writing things that are so low level, but it's just easier, at least for me. If you want to resolve 1,000 dependencies, if that's your thing, more power to you. So I'm going to inject a DLL rather than write a whole bunch of. I'm going to make my own assembly, my own little binary, and I'm going to have this call it. So I'm calling, new code that I wrote. I'm introducing a whole set of new code into this application. Not really super magic, but it kind of drives the point. You can figure out what that point is. There's a couple ways to go around strong name signing. If you're just doing this for your own personal edification, just to muck around with an application, maybe you're trying to figure out why it does something, or try to get it to hit in a certain place, and you figure, I'm just going to modify it. Sometimes that works when you're playing around with rendering or whatever. Just kind of exploring the application. You just want to insert maybe some breakpoints in there that pop it up and be like, I'm in this function now, I'm in this function now, I'm in this function now. You can do that by just registering it for local bypass of strong name signing in IDA ASLM.exe. I will put this in a blog post, I swear to you. I really mean it this time. Or you can remove the reference to the strong name signing itself by modifying the binary. Now, this is a dark magic in and of its own talk, like many things I will say here. And I'll try to put up a blog post. There have been blog posts written about it, and it's different in every different version of .NET. So, God be with you. But you can see here, here's one that's signed, here's one that's not. You can see that there's this blob index that's different. There's a lot of references, and that's referencing the public key. It's not just as easy as changing it from 2.4BB7 to 1. There's other references you gotta remove out there. Like I said, it's different for every version of .NET, so I can't really get into it here. But if you want to have an executable that's going to run on other machines than your own, you've got to do this little hard surgery. So, my next step, I got to figure out how this toolbar is getting thrown. That's what the toolbar looks like in Reflector for people who haven't used Reflector. I can't find it. It's obfuscated, right? All my methods, so I ran de4.de to remove the smart assembly obfuscation. Smart assembly is actually in my experience, one of the easiest obfuscations to remove. Thanks, Ricky. Crypto obfuscator is the hardest. It messes up a lot. Sometimes you just can't do it. I gotta find out where this toolbar is implemented. But none of these classes have meaningful names anymore because they used to be garbage and was converted back to generic class 511 method 29. But the string is always going to be the same. If we strip off the string eventually has to be made into a printable format, whether it's encrypted and decrypted somewhere, or if it's just in plain text, or it's encoded and then they decode it. It's eventually got to show up like that in the application. So that's what I'm going to search for. Now I'm just going to say this: don't use the inline reflector search. It's horrible. It will take you years. There's this nice tool. It's free. It's actually linked on the Redgate website. Code search. It has saved my life. So I'm just searching for that string, assembly source code, and I find out there's all this iCommand bar references. iCommand bar, that sounds like something that might be a command bar. And then you see where they're making all of your little references, I don't see any references to icons, so that's probably in the toolbar thing, and I'll get into that later. But this is just, reversing 101. You find out where something you know is, and then you just have to crawl down the path of calls. Write a lot of notes, because you'll have to go back up your tree. So now I'm going to add a new reference, add a new toolbar icon. Basically, I'm just going to clone one of these, but I've got to write the IL. You can see what the IL looks like here. The functionality is supposed to be a surprise, but you can probably figure it out by now. So I'm saying call this method 29, which instantiates command bar. Basically, I'm using a tool called Reflexel. You can inject this call by opcode. You can just insert those opcodes in there, one at a time. Now, if you don't know IL, just write it in C#, compile it in Visual Studio, and then switch it to ILView, your tool of choice. CFF Explorer, Reflector has it as well. I think there's an in-house one in .NET now, but I try actually not to be in .NET a lot, or Visual Studio. I don't even. Anyway, so I'm just injecting and loading my string. It's going to call application.iam. I've got to define that later. It's calling the method that makes the command bar. It's loading the string that's going to make you a little rollover text. This LDC I40 is just loading a numeric value 0 on the stack. That is because I don't need any key bindings. If I needed key bindings, I'd have to assign a number that referred to that key binding. If you look at some of the other code, you would see other numbers that would refer to like Control A, Control B, Control C. I don't need that. I'm not going to get that fancy. So that's just one example of injecting your IL. You're just writing new code and just sticking it in there. You just save it, and this is the part that sucks. You save it, you run it. If it doesn't run, then you go back and figure it out. There's no like debugging in here because you're basically just fucking with a straight binary, even though it's got a fancy layer on it. It's got a straight binary. So now I got to find out. So this is what the new IL is in a more readable format. I won't get into it because I've already talked about it for way too long. How many? I have 15 more minutes, I think. Okay. So I'll go a little faster. So I wanted to add, I had to find out where this little toolbar, where all these icons. Like I said, they could be referencing the file system or they could be inline resources. Reflector is really good about just giving you a little folder that has all of the inline resources. So I look for one, and I see that there's a bunch of things called command bar, so I start looking at them. And I find the one that, it's all the icons. It's just carving them out 16 by 16 somewhere and popping them in there. So I'm just going to pop a new one on the end. And that's all I did. I just modified this, reloaded it in. You can actually edit it. You can either upload a file. Reflexel just lets you do this. You can just re-upload a file in there. Modify it, re-upload it, make sure it works. Okay? Then I have to find the part where it executes this thing. Like I said, there's a lot more to this. I'll go through step by step in the blog. I just kind of want to touch on like the high level points. the logic behind this and what it looks like when you're working with these particular tools. You know, this is not going to get anyone reversing right away. Actually, no, you're all really smart. You can figure this out because I didn't. I'm not that smart. So I look for things called like execute and query status. I basically I tried going up the tree and I got lost. Again, attention to ADHD, whatever. It's not good. Don't let your kids get ADHD. Don't let them eat Pop Rocks for dinner like my kid. So I thought, let's start looking for things like execute. There's a lot of things called execute. I finally found it. It was also good that I knew that I only had to look in a certain class. Because the class, I knew that it was going to be near class 269, so I knew that at somewhere near class 269, and maybe in class 269, if I'm lucky, is going to be this execute code. And there it is, I finally found it. So I only have to look in one of, I don't know, 300 generic classes, generically linked classes. So this one was called execute, which is good. And you see that they're basically making a dictionary. And they're making a dictionary of application calls. So I need to add a new dictionary head. And I did. And that's what the code for that looks like. Should have put a background on that. I'm sorry. But I'm just loading a string, loading an ID, a new dictionary number, and calling out to the Microsoft Core Library dictionary class. Yeah. Now I need to inject a method. I need to inject a new function because this is adding a dictionary of function calls and then assigning the new function call to based on the dictionary number. Now I got to inject my new function because I mapped the dictionary to a function. Function doesn't exist yet. This isn't going to work. So Reflex will let you inject a method. I'm injecting it in the class where all the other methods I see are. They're generic because they were encoded or modified before. Obfuscated, I guess, is a better word for it. So I made mine have a nice name. I didn't use a generic name. But all it's doing is calling out to my DLL. And I'll show you how I get my DLL in there. But my DLL is, very graceful, very well formed naming convention. Has a show form function in it inside a class called her. And so I insert, this is the CIL for my new Nyan function. Okay? Then I have to insert the reference to my class. My DLL is called dirt. It has the her and the show form functionality in it. Inject assembly reference. It's so easy. I feel like the slap chop guy. And that made it seem really, really easier than it was, but there was basically, I'd say in terms of total man-hour took about 2 weeks. And I've been doing this for a while. I think if you maybe start out with something that isn't quite so junky looking. Maybe start out with some clean code that's not been obfuscated if you can find it. Or just write your own code and just muck around with modifying the IL instead of modifying the C# or the Visual Basic or, God forbid, the F#. And let's take a look at what we did. Can I get a desktop? Yes. So here's my I made 2 versions. Because I know that people don't really look highly on this kind of reverse engineering. They're like the low-level IDA stuff. But one of the reasons that I was inspired to do this talk was because I was sitting next to somebody who spent all of his time on IDA, just like 18 hours a day in IDA. He's a beast. And he was, I shout out to him in my thanks, Aaron Portnoy. And I all the time, but he'd open it up and he'd be like, damn it, it's .NET. Damn it, it's Java. He's like, someone needs to do a talk on how to do this, because I don't know how to do this really easily because I'm so used to using IDA. So I made 2. I made this one, which is my favorite. But first, for everyone who decides that they really don't like doing this .NET reversing thing, here you go. This is for you guys. All right? So it's like when frustrated, hit IDA button, do something that is a little bit cooler. And then for the sorely needed Nyan cat mode in Reflector, there's sound, but there's no, I'm not gonna. like I said, I'm not doing anything new or groundbreaking here. I'm sorry I'm not going to drop any O-Day. I'm not here by a representative of my employer, but I don't think they'd be happy if I did that anyway. So, how do I get back in here? These are already, come on, yeah. These are already up on my blog, and they're really hard to read because they're all visited links, or I'm really not good at formatting slides, I'm sorry. These are all up on my blog already. I'll also put up the reference for the .NET file format, all the role tables, the mod def, and metadata tables and all that stuff. I'll put up a link to that because it's all, like I said, all documented. But these are all the things I used. I started out with this anatomy of a .NET assembly, found out about CFF and Explorer, started clicking around there. ILSfile is a decompiler that's free, that doesn't have a trial, that you would have to figure out a way to get around. I heard a credit card is a good way. There's, yes. There's Redgate, our favorite, Rick Rowland, Smart Assembly, and Reflect. They also have an obfuscation checker. They're just, yeah. I don't even know what to say about it. Reflexel is the thing I'm injecting the IL in. You can actually go in and write your own IL, like in CFF Explorer, and basically, the process for that is a little bit different. Some people like doing it with CFF Explorer, writing it and rolling it back in, whatever that process is. I'll probably try to, I'm more comfortable with Reflexel because it slows me down. You have to insert one command at a time, or one opcode at a time, so that you really think about what you're doing. If you're inserting massive quantities of code, probably want to do it the other way, or probably want to write it yourself in a DLL and see if you can call out to it. Otherwise, you're going to be writing a lot of stuff. You're doing a lot of right clicking. Code search is the thing that's better than reflector code search. Yo. And the D for deobfuscator, if you run the obfuscation code, it works really well. It is also open source, so if you want to see how they're actually doing that, how they're accomplishing it, doing a little bit of study on how to get around that, then you can read through the code. Or you can write your own if you come across a new one. Again. Anyway, so this is the question slide. I think I have 12 more minutes. Like I said, I talk really fast. But you can get me on Twitter. I'm that annoying girl, Aloria. I'm sort of a jerk. Apologize in advance. Or email me or hit me up on my blog. I know that some people would rather be wandering around the conference and such. I don't plan on drinking today, so I'll actually be a nice person. I apologize to everyone yesterday who I was mean to while I was drunk. Anyway, any questions? Bueller? No? Nobody? Awesome. I can either give a really good talk or a really bad one. Okay. Well, thanks everyone for putting up with me. And thanks to BruCON for having me. Belgium is a lovely, lovely country, and I'm so happy that I got to visit. Not to be overly sentimental or anything, but it is really an awesome country. So you guys rock. Thanks.